Hello, welcome to this class, and my name is Darlens in Gospel. In this class, I want to teach you about mappings in Solidity. All right, what are mappings? Mappings are another kind of data structure, just like an array, but it's not an array like an array. Okay, I may be getting you confused there. But think about a mapping like an associative array in some programming language such as PHP, or think about it like a hash table or a dictionary in Python. So what it does is to store values in key and value. So it stores data in key value pair. So each data has a unique key and each value as well. So that is what a mapping is all about in Solidity. So without talking too much, let's get into the code and see how we can utilize it. Fantastic. So let's declare a mapping. Let's call this this is how you start a mapping. Okay, just say mapping. Sure, you always end with semicolon, and of course the name of this mapping must be public. You can make it public though, let's just make it public though for now, and let's say balance of. Okay, so this mapping, what we want to do is want to create like a crowdfunding application where people actually send money and each person have a track record of their own account, so we can be able to track how much Adams have sent to us and how much Bimbo have sent to us, so we'll be able to check everybody's account balances. So how you do that? An address is a unique kind of data type. So that means there can be no two persons with the same address. So we want to use that to specify the amount that each account is going to have. So you say address is mapped to what? uint 256. So this uint 256 is going to be the balance of this particular address. So this is how you actually map and do mappings. All right, in Solidity in the simplest way. There is also a two-dimensional mapping, but I don't want to take you to that crazy lane for now. I want to keep things simple because this is what mastering Solidity basics. Remember that. So with this noted, I want you to come in here and say, let's say write function and call it make payment, or let's call it donate. All right, and for a function to be, let's make it public, of course, because we're talking to the public. And for a function to be able to receive money, it must be payable. Okay, it must be payable. If it ain't payable, it ain't gonna work. So you say payable, and this returns true. So it's boolean that is returning. So at the end of that function, the last thing that must return back is what? A boolean. Okay, but you can actually ignore all this and just say that this function should just perform this little piece of code. And now you can say once this payment is made, what we want to do is to access this balance of this owner, which the owner msg.sender, which is this particular person that just made this payment to us, and we want to increment the account by msg.value. So whatever they sent to us is going to be recorded in the account as what they have donated to us so far. Okay, so with that done, we need to get that is it. We can use the other account to actually access the individual's balance. So let's say this is compiling for real. Yeah, fantastic. And of course, let us compile the smart contract. Let's compile. Good. Open this thing up. Please take note, this donate function is red in color because of this payable clause that we added to it. Payable makes a function to be what? The button to be red, and that is in remix ID. So right now, for example, let's change this account. Let's use this last one. Let's copy the wallet address. Okay, and we want to check how much does this guy have now. Has 0 because he has not made any payment to us. Okay, so now for him to make payment, let's specify how much he wants to make to us. Let's say 4 ethers, that is what he's making to us, and let's click on this donate button, and it's donated. Now let's click on what? Balance of this. You see that we now have what? 4 ethers, and this is a representation of 4 ethers in we. All right, so if this same guy comes back and donates 2 more ethers to us, we'll be able to click that donate function and perform this. You see that we now have what? 6. So this is for this particular guy's account. So what if we change this account? Come in here, let's copy this. Let's copy this here and change this. You see that this person has no form of donation, has no money with us. This is what the mapping variable, the mapping data structure is doing for us, the associative array thing going on. So let's say this person comes here and donate 3 ethers to us, donate, and then we check his balance. This is what he get. Okay, and we can do that again for a different person, and let's check this different person's balance. The balance of this person is 0, and this person can donate let's say 1 ether, and click on this donate and check the balance of this person is now 1 ether. Isn't that fantastic? So with that, you can come and play with all of this. You can check. Okay, let's check this person that has made donations to us before. Come here, and place this, check the balance of this person. You see it's 3. It's keeping track of each and everybody's donation because of that simple thing. Let's check this. See, this is 6. So this is basically how the mapping's data structure is doing. What is happening here, for every address that I enter into this mapping structure, it will return the amount of money that this person has donated to us. So that is what the mapping structure, that is how it feels like, that is how it works like. It's almost like an array, like you see how I using assigning it, but it's not really like an array. In Solidity it's called mapping, and that is how it functions. So hope you got some cool value from that. See how slick you can actually use that to do some really cool stuff in Solidity. So that is how you use mapping. All right, so I hit you in the next class. Click like and subscribe. Thank you. Bye.